Why is there no move assign actually? There is an assign. This is a move assign. This one is a count. Okay, it's different of course. But it assigns a whole list. Never mind. No, kind of strange. Yeah. Well, yeah, okay. I'm contemplating introducing a function somehow that takes a universal reference, so I can stand it forward that. I think this signature, these two signatures must exist separately. Not really there to make that a single pushback. But that would be easy to just inline that and then call the new function. The only benefit then would be that I can send it forward, send forward the argument to create node. So then this implementation exists just once. And that would mean that every invocation of pushback can make use of that then. But that means I need several of them that no, wait a minute, not push back. Combination of create node with pushback node. For example, these two. This insert. I would still have to make another wrapper then for that. Or make this a wrapper that calls the private insert. But then this code becomes the same thing. So just call here the standard forward of the argument. And the rest is the same. You grow the value. Yeah. Especially if I can combine that with the insert. The inserts that I still have to write. I already have that one. But there is more inserts. For example, this one, count value. That looks a lot like the assign, however. These three are actually assigns. The assign is a clear followed by this insert. But that doesn't benefit from what I just said. Maybe the place will benefit from it. Place is kind of the same as... Oh, wait a minute. This is a universal reference. So I can abuse in place, I think, to implement both of the inserts. Just pass arguments in a way that the copy constructor and or the move constructor are being called. Except that place itself is not returning an iterator. At least this one isn't. Place back. And place returning an iterator, right? Yeah. So that is the same as the insert. Return all iterators. Let's begin with implementing the place. Before I think about this. Though I already added this one, but well. There is no in place. Damn AI. I had to generate this list and then it just leaves out in place. It should go before erase, so in between here. Not my style to use class. I prefer type name for templates. But we'll fix that right now. Template class, template class, template class, template class, template class, template class. Yeah, I think I just replace all of them. So I think that this end place is probably extremely close to, let's say, well, either of these. In fact, I'm going to put place a board. Doesn't make any difference, but I like to declare stuff before inline functions that use it. Though I think the compiler just processes the whole class first. A whole class definition before, you know, so the order doesn't really matter. Nevertheless, let's do an insert here. Yeah, copy it in the mouse. Or no. Nope. Iterator list in place. So places like insert, right? Just insert it before pos using those arguments. So we can just copy this. And then call create node, not with value but with forward standard forward. Args. Same thing here. So any argument, the argument list or whatever, a single argument that is being passed through in place is passed with the same type to create node, which means that if we have a single argument of type T constant reference, it's exactly the same as this code. I can just call in place from here. So we can do return in place pos comma value, which then uses that code. And then of course make it inline. And for this one too. I have to move it, but so I'm going to remove this and this and this. Put it on one line. Same thing here. And I'll just inline it. That was insert. And I can move the assigns down. And I'm also do them in line. I just start with a clear. And then we call insert. Get the same arguments. Now this insert here has an ilist by value, so that is not what you really would want. I think I'm afraid I have to ask it on IRC. It's in a record C++ pure. ask it in generic. So I'm typing, I'm running a linked list which has the member function seems that this must take the initializer list by value as per cpp reference.com. Now I want to implement which also the assign, which also must take the initializer list by value as does this make an extra copy of the initializer list? So can that be avoided? Maybe initializer list is very small though. Maybe it is pointing to something. Maybe it just has a begin and end iterator. In which case it maybe is only 16 bytes. So then I wouldn't really care about a copy. I guess we are just going to take the time to test that. I can of course use just a standard list for testing that. So let's say abuse my test program, which is here. Let's put it at the end. So just make a standard list. Yeah, but kind of, no, wait a minute, this is bullshit. No, I really want to have an initializer list. How does that work? The most unfriendly person on IRC gave me an answer, but in an unfriendly way. Still don't know anything. I'll answer. Doesn't that copy all elements of the list? Why, he says, why do you care? Oh, fuck. Okay, anyway. I list. So I think we can construct that from multiple datas, which might or might not Standard initializer list is pretty much a view type with compiler magic on it. It consists of pointer plus size slash pointer plus pointer. Copying is hardly a costly occurrence. Yeah, okay, so we don't have to do tests anymore, I guess, but let's do the test anyway. So let's add several data objects here as an initializer list. And then the initializer list itself is going to be small, apparently. Hopefully. Does this compile? Nope. The definition of a sign. Silence. No, I don't. No, not really. I'm always interested in offers, but people don't want to hire me if I say under what kind of conditions, like I want to work from home or stuff like that. Initializer list. I'm from the Netherlands. $16 as predict, no, as I hoped. It's just 2 pointers, okay, or a pointer on the size type, indeed. So I guess I don't really care about the thing being passed by value, and it is going to make a copy. There's nothing you can do about it. Okay, what was I working on? Something with initializer list. Whoops. Insert. Yeah, here it is. So I could try to move it, but the whole thing is just 2 pointers, so there is nothing to move. It's a move in itself, as it were. I still have to implement these 3 asserts. But they share the code that I already have. So the assigns, basically I can just replace assign with insert, remove the clear, and then you have the same code. Zip, no clear. Okay, I'm gonna inline that one as well. Except that I don't want to call pushback because pushback is now well, it is going to be implemented as in place back. Haha. Didn't do that yet, or this is a completely different thing. T vector. So instead of calling pushback, you might as well call in place back directly. I'm writing a doubly linked list. See the description. So the dereference of the current thing is definitely going to be a value type reference from, maybe I want to force it to be const. Otherwise, I'm not sure it's going to call the copy constructor. Yeah, I think it should be the const. So current input iterators fake. You don't know what it is. I could also just call pushback, of course. Maybe I'm being an idiot again. That sounds like a const reference. Might as well inline these things. But yeah, I mean, if it is a loop, why inline it? But I do want to inline this one. Oh, what? Oh, yeah, never mind. So the assign things start with the size type. I need a pause. So So we must pass an iterator here before we want to insert it. So that would be end. If curse, and I have something in my mouse bar or in the basic, that thing. That is an insert. That is must return an iterator. Yeah, see, it's not the same thing. Const pos. So that thing would be something that returns an insert at the same pos. So that's just implemented in terms of that one. And then of course this one and the other one must be given a const iterator where we want to insert stuff before. That is annoying. That's not in place back then, huh? It's not in place back. This is just in place before. I think that is doable in this case because it's the linked list. I mean, doable is it's not inefficient. In place takes a pos iterator. However, now we are inverting the thing. So we take the first element and we insert it before pos, and then we take the second element and then we insert that in front of pos. Oh, that works actually. If you insert something before pos, then pos itself is not invalidated. There is just one tiny problem. If pos is the end iterator, I'm not allowed to call in place. Or am I? Yeah, of course, in place should just work. Yeah, and place already does this check. If pos is end, then we use a pushback node, otherwise we use insert node. So the only thing I have here is, well, not inlined, are the things with the loop. Insert before pos, count times the value t. So it doesn't even matter what the order is. Even if it would be reversed, it's all the same value. This one is slightly different, of course. But yeah, as long as you insert before pos, then we have to start at current, not with last. So that is correct. Yeah, so these are implemented in terms of in place. There is a single in place, and then this one is also implemented in terms of in place, and this one is implemented in terms of in place. And this one is also, but that's defined below, and this one is defined below, and this one is implemented in terms of this insert. And then the assigns are implemented in terms of insert as well, which are all implemented in terms of in place. So the whole everything is in place now. However, now I'm passing arbitrary arguments to create node, so we have to fix create node. To allow for that, so we get just one create node now, which then looks a lot like in place. Let's find the in place back. Here's the in place. Yeah, as if I can remember this. And then we have only one create node. Create new node, allocate one thing, construct. And now this construct better work with multiple arguments, or I'm completely screwed. No, I suppose it does. I hope it does, damn it. Uh-oh, I was holding my breath, but it didn't help. No declaration matches. Oh, wait a minute. Maybe we are still in the clear. It's just an error that I made. No declaration matches insert const iterators size type. Const iterator pos size type count. It's like right here. What? Oh, it's returning an iterator. Okay, never said anything. It's completely right that this thing must return an iterator. Oh, right. And what does it return then? Actually, maybe it shouldn't return an iterator. Or should it? Huh? What? Count 3 inserts count copies of the value before pos. Return value 3 iterator pointing to the first element inserted, or pos if count equals 0. Oh, this is also possible. So we're definitely going to return pos then. And then pos must be set to the first element that is inserted. and place returns iterator to the new node that it inserts. So maybe that doesn't really work. Let's just return the result. So we're going to create an iterator result from pos. And then we have to change that if the count is larger than 0. Nah. Bullshit. Let's do this as follows. If unlikely count equals 0. Return pos. So count is not 0, therefore we can now do pos becomes and place pos value. That's the first one. Insert first element. Wait a minute, if then I insert all the other elements in front of that, well, I might as well do that. Well, might as well do that. Okay. Oh, yeah, nah, yeah. It's on the stick. Who cares? I'm just gonna assign here pos. We don't have to do this. So if count is 0, then we return pos. Otherwise, we insert before pos, as should be, and then assign that pos. So we now insert the last one first, and the one that comes up front last. But that then gives us the position of the first element. Now, and here it is definitely different. Is that going to be returning what? The iterator pointing to the first element inserted, or pos if IList is empty. So this is slightly different, unless we insert them in the reverse order. So now you have, if I assign to pos all the time, then we have to do current last. So we have to start with last, and then decrement current, or rather, okay, I'll just call it call this first. I'll make a copy of something. Put iterator current is last. No, actually, last is not the last one. Last is one past the last one. What do they call that here? It is called last. 4. Insert element in the range from, but not including last. I would call it end. So I guess we just have to do something like while current is unequal first. Just going to call the last current. Well, it's not current then, but it's one beyond current. No, then I'll call it lost. Whatever, dude. So if first equals lost, then we don't do anything. Otherwise, we decrement lost and then dereference it. I think this is correct. Iterator does not name a type. Yeah, just from the same list. Type from the list. Oh, wait a minute. It's not like that. It's input iterator. Which, that's what is returned. No, but it is returning an iterator. Huh? So we have an input iterator and it returns an iterator. Oh yeah, I'm a complete idiot. Pos is a const iterator. Duh. Let's see, this was a const iterator, I hope. No, it's an iterator. Can't use pos. Yeah, const is also an iterator. Fuck this. Iterator. Let's call this current then. It's pos. That can't work either. You can do a cast, I guess. The cleanest way, I think, is just use a cast. Yeah, you can't assign a const iterator to an iterator, but the first assignment is just going to be passed again to mPlace, which takes a const iterator, and that that function returns a normal iterator, which we can return. Must say I'm not very happy. I would rather mPlace before pos all the time. Oh, wait a minute. No, my iterator 2 const iterator is very efficient. I can just use a static cast here. It's not a reference, but do we get something like the pointer of pos? It's all too dirty. It's just too dirty for words, this. What is a normal way you would cast an oh shit. Okay, I'm gonna do this differently. I don't like cast here, so I'm still going to do the count equals 0. So now we know that we want to call this one once. But yeah, life is not that easy for this one. Or actually, probably it is. We just have to iterate starting at the end. And I was doing that anyway, already here. So it's kind of the same thing then. Let's see, so no, that can't be right. Okay, I'm totally messing up here. Let me think. First of all, we have to dereference the first element in order to get the first element. So I want to insert before pos. Now I know only actually that we only have at least have one element, and that element is then going to initialize first, but I mean I can't use a pos, right? Because pos is a const iterator. So we make first, which is type iterator, and so we can return that. And it can be assigned from the call to and place, and I want the first element to be the one up front. And I kind of, don't ask why, but I kind of want to in place all the time before pos. So that means that you have to start at the back, and then the last in place is first. So really I want to start with inserting all elements except first. So I decrement last, because last is one past the thing. And if that is unequal first, we can just in place it. Before pos, dereferencing last, like that. And then we do that at the end. And then I'm the person that's just the one more in place. And then this is the same as that actually. So we get here at the moment that last equals first. As soon as last equals first, then this is false, so then we fall through and then we insert that one, which means that that is the first element. That's why I just like to call last current, because otherwise it's totally not readable. Beautiful. I think we did it. Didn't test it, of course, but that's so much code. I don't feel like testing it. They should be already on the internet. Double linked list test suite. Don't ask me to write a test suite for something this standard. That's ridiculous. I think I'm just going to implement everything and then look for the already existing test suite. Next one is erase. The push back looks kind of suspicious here. Thought I already did that one, namely. Yeah, I did. I just don't like it to have this code duplication. I don't want to. I can implement these things thus in the same way in terms of emplace back. Evil laughter. So there is an emplace back, right? Well, not in my list, it seems. Really? Of course there's an emplace back. There must be an emplace back. I just don't see it here. There's my emplace back. Do we implement that one as well then? It's exactly the same as a place, except that you don't pass the end pointer. And then you would say, well, implement it in that one, but no, because this is a special case. In our case, this is a special case. So I'm going to separately implement it. Place back. Yeah, besides it returns a reference, but still. I could just call this and then dereference the iterator and then it would work. But I think I want to implement it separately. Let's put that one here. List. The list stuff and the member function stuff. And the reference is an element of the list, as is of course the member function. And basically, and this is the same as that one where you use end as pos. It inserts before end. But that means that pos equals end, so I might as well, I mean, I can leave this out. It's just shorter. I just do this. So we create a new node. And then we call pushback node, because it is at the end. And then we return a reference. So we don't return an iterator, we return a reference to the new node, right? I have to still cast it though. I have to cast it back to a value type. A new node is a node type because create node creates a value type and then casts it to a node type. Seriously, yeah, node cast. It was a value, but the cast is just no assembly code at all. No, actually it is. Node is has an offset, so this adds or subtracts something from the pointer. Oh well. So I do have a value cost, which costs the whole thing back. So except that it doesn't get a color, so I don't have a value cost. Oh, I called it value type cost. Now it does have a color. And that returns a value type pointer given a node pointer, and then we have to return a reference. So I have to dereference the pointer. Yes, pretty sure that is correct. And now the thing that goes wrong is that it doesn't know where the value cost is. The value type cost is a static function of the base. So just call this a list base t. Or not. Error cannot be overloaded. Previous declaration. Back. I think I already had a place back. What the hell? Oh, I did have a place back. I just didn't see it. Okay. Goodbye. Then we have to, okay, now I have an in place and an in place back, and then we can implement the insert back, sorry, the push back in terms of the in place back. Kind of the same way as we did here. Push back, push back, push back. Insert, right? Place back from the value. In my opinion, that should work. Now we have a push front. So the big question is, of course, do we have an in place front? Yes, there it is, in place front. So let's implement this one first. And then do the push front in terms of that, methinks. Pop front is part of the base class. Let's make this also part of the base class. I don't think that the pushes cannot be, because in the end all the in places cannot be, because in place calls create node, which uses the allocator. Can't even find it, but so So anything that actually inserts something cannot be a part of the base class. Erase probably also not. Also has to call something on the allocator. But yeah, the pop back can definitely be put here. I'm gonna write an extract back. I mean, the whole thing is so symmetrical. I cannot believe that I won't need it. Oh, wait a minute. Didn't I? Oh, no, I did. I wanted that, and then I didn't. So this is still not updating size. So we have to still deal with size update in the same way. Subtract that, and then if size becomes 0, then we have to change the base pointer. So we can do that as an afterthought, hopefully. I have to think about that. I guess this is kind of the same thing then. Extract back. Do something. So in the end we will return the last element which we just removed. Probably the same as this. So begin and last back everything. Is it now back or last? I'm gonna call it last. So last is something, and then we do return value cast last, which we just returned. Now, what is the last element? The last element does exist, otherwise you're not allowed to call extract back. I mean, you're not allowed to call pop on an empty list, period. Undefined behavior. So we can assume that last exists, which is then the untainted value of the previous of the base node. Yeah, base node previous points to the last element. Which means that we have to update stuff. I'm looking at this. I can hardly believe that this is correct. How can a doubly linked list have removed one element and then update only a single pointer? Just wrong. Aha. Okay, let's fix this one. Okay, begin is the first element. And if I call this begin, then maybe I should call the other one last. Oh, I did that. Or you can call this one first, but no, let's call it begin. It's the first element of the whole list, which is usually called begin. Man, I'm probably getting tired or something because I suddenly don't see it anymore. Let's draw some ASCII art. So we have the base node. Next points to the front. It's the first element. And next of that points to the second element. And then we point back to the base node from front previous, to which was pointed to by the second element previous. I don't care about the next, let's just do it like this. We want to remove this whole element. So base node next becomes this thing, which is, I'm not calling it begin, damn it. Substitute front with begin. Yeah, so begin itself is base node next. Base node next points to begin, so that's correct. And then the next of that is the second element. So base node next becomes the second element. But we also have to change the second element previous, which means that that second element that we're now pointing to, previous, must become the base node. So that one was missing. And then the interesting case is where this is the last element that you remove, in which case the second element is actually equal to the base node. So then you get that the base node is pointing to itself afterwards. But that also means that this is the previous of the base node, because next points to the base node, and then you get again the previous of the base node. And that one must be tainted. So this corrupts my list if you remove the last element. But we didn't update size. We do that here. So if we now see that the size became 0, then we fix it. So we taint the previous. The base node previous must be tainted. So that just at the least significant bit is being set. But it definitely does something if the list is empty, because if the list is already empty, then begin equals base node, because next point to the base node. Begin next is again the base node. So okay, next is assigned to base node, which is what it was, and then we assign here previous base node. So what it does is it does reset the taint. And it returns the base node, which you don't want that. I'm just gonna say that you're not allowed to call it when it is empty. Which is, I think, trivial. Extract front. I mean, if the thing is empty, then there's nothing to extract. And here we get from. Base node previous. So this removes last. This is the last one, the last node. No, it's no longer there. So we get node. The last node is pointed to by previous base node, which must be untainted because it has a least significant bit is set on that thing. So now it's the correct pointer pointing to last. And then I have to, just like here, update two things. Namely this one and that one. Well, we did previous last, so let's do this one. So that one must be tainted because it's the previous of the base. And it must be set to this element. Which is pointed to by last previous. It's gonna make sense, I guess. Yeah. Not sure about the order though. Like, yeah, we override next and then use it. Begin next was never changed. I might as well use begin next. I got it. Next previous, yeah. Okay, I need access to the second element again, which was last previous. And then the next of that. And that must point to the base node. So this does already taint the previous, because this is even necessary if the list is not empty and there is no other assigned to a previous. So it's no need here to fix something. Fix the taint is corrected, is already correct. So I add this comment here, but not here. Okay, so that was extract back, which you then can call here, and then this is indeed not necessary, but we still need to decrement the size, of course. Yeah, I implemented pushback now in terms of and place back. This is doing create node and then pushback node, and now it's doing create node and then pushback node, and it does return something which is then ignored. I think the compiler can deal with that, although this is not inlined. So you might actually have the problem that if this thing is not inlined, that it will put something on the stack and then ignore it. It's something being new node, but it probably uses the stack for that already. However, this cast requires an offset, so we lose one clock cycle there. I guess I'll just accept that. I'm not really testing anything because I'm just coding stuff and not adding tests for it, but okay. Clause list from the top. And that was a favorite of me. From the top TikTok movies or shorts. Good times. Erase, is that the next one? I think so. It's just a lot of boring work, that's what it is. There seems also to be no end to it. So erase is going to remove something from the middle. Highly annoying. Yeah, I really hate anything that has to do with updating the pointers. So I think the erase is kind of the last one, isn't it? I mean, the rest can be done in terms of what we then already have, like a resize. Yeah. I think resize is just calling this swap. Didn't already do swap. And then merges may be interesting, at least. And definitely can be done in terms of. Splice, I never even used that. I don't know what it does. Remove. Okay. Why do all those things exist? Reverse is annoying. Unique, also annoying. Sort, challenge. Equals, annoying. And then we're done. Poo-poo. At least this one is one that can be accelerated a little bit. Not going to loop over it and then remove one element at a time. Yeah, erase is a lot like extract. So extract front or back. So maybe I should not have written extract front or and back, but just extract something in the middle. And then I think that my preference would be this one, because it doesn't fuck up the taint. So we get rid of extract back and then simply extract something from a given iterator. So we just pass that and then we're done, right? Well, almost. With the base node, could pass the base node. I mean, the thing is circular, so we just pass a node that happens to be the base node. Then we have to extract back. Then we pass something else and it removes. Yeah, well, okay. Is this different? It is, of course, a little bit different. It's definitely different because of this. Okay, is int. We have an in place. Maybe I can just write erase in terms of that, which then means that we have a push back node or the extract back. And then separately you have insert node or extract node. So I need to write an extract node, which is then not allowed to be called if it is the last element. Comparing it with this same but insert before pause. Pause is not allowed to be end. So kind of a counter thing. I have push back and then we write insert node, which gets an iterator passed. And now I have an extract back, and I'm going to add an extract, right? Or erase, nah, extract. Node. Which is going to be the counterpart of that one in the same way as the insert node is the one that completes the push back node. This, however, does update size type. But okay. I think erase takes a const reference. That was changed in C++ 17 or something. Erase. No, it's in C++ 11 even. Takes a const reference anyway. So we do a C++, sorry, add a position here. So okay, that and then I guess it will return a value type. And now we can copy the comment as well, like pause is not allowed. Well, the problem though is that then we do not extract pos, but we do extract the element before pos, apparently. Well, if we do that, then pos is also not allowed to be begin. That would be extract front. I have a feeling I'm doing something nonsensical, but okay. What to do? It's not easy to add one. I'm just going to add one here. Is that too ugly? You can do this. Nah, it's also not Now we want to remove, in terms of ASCII art, the thing in the middle. So apparently this is pos. I'll just call it pos. Which then kind of makes this just pos -1, right? Okay, now what is wrong here? In this case we have passed, we just get a node pointer, and here we have an iterator. Do I care about iterators here? Not really. Give me a node pointer already. And then of course it is pos that all these things are pointers. What am I doing? This is a pointer, and that is a pointer, and that is a pointer, and everything is a pointer. Loss is actually also a pointer here. Base class node is not a pointer. And yeah, this doesn't matter because I'm not using it as a thing. But why not make it a pointer? Second last pointer. Now begin is a pointer. Second element, make that a pointer as well. So I have to make everything a pointer except the base node. From, another very good series. Yeah. Dun, dun, dun. No, but do we have was last one, this one. Extract node before pos. So because pos is not begin and not end, it is a non-empty list. Is it even more than non-empty? So suppose it has, if it is empty, you can not extract anything. It has only one element, you're not allowed to call this. because then it's both begin and the last one. Well, the one before. So yeah, you can only extract one element, which means that it has to be end. And it can never be begin, but it can also not be end. So it must have at least two elements then, the list. So if this thing is not end, it could be last, which means that this is also not base node. This could be begin. So this could be the base node, theoretically. But the next pointer of the base node is not tainted, so we don't have to take that into account. So there's nothing tainted here, and we can just do whatever we want, assuming there is no base node. Which means that now pos -1 is pointed to by pos previous, which we then return. And then we have to update this one and this one. Let's first let's first update this one, and then the next pointer can be updated. So that one must become the thing that points to this, which is this. And we have pos -1, so we can just assign pos previous becomes, pos previous must point to this object, which is currently pointed to by that one. So this is updated now, and then we have to update this, where this object is now pointed to by that thing. We just assigned that. So that next becomes this thing, which is just pos -1 then, of course. No way this is correct. This cannot be. Sorry, no. This has to point to pos, not pos -1. Yep. It points to pos. Yeah. So now I can use this to implement erase. Can I just do that inline? No, cannot do that inline. iterator. So again, member. I have something in my mouse buffer. I've called what? Not that. Let's paste that here. Okay, so now I need the next pointer of. Don't think we have that. Let me see. Iterator. I just have pointer. Okay, that's bullshit. I want to do that if it is not begin. Okay, so if it is begin, we must call extract front, and if we call extract front, then we must fix detained, which is exactly the same as this, except that we now remember the return value of extract front. Or rather we should. What the hell? I keep casting, man. This is very annoying. Maybe I should just not cast in these private things. Just return a node and do the cast after, when I really need a value type. So doing that. So node pointer. Node is extract front. And then I create an iterator. Why not from the node? But yeah, I have a return here, so it's kind of nonsensical to do anything else. So this must be extract back. Why doesn't it get a color? Extract back. I'm going to just return node types here. Do the cast or get compile errors. already can be constructed from a node pointer. Okay, I've totally forgot where I was. Somewhere at the end. Here. So erase. If erase is an is equal to, its position is end, then we want to erase end. No, that's just not what we want. Damn it. This cannot be empty. Sorry, this cannot be end. I can just increment it. Seems actually more logical. Do position. What does erase return anyway? I think it does return the element after what is erased. Wouldn't that be cool? Return value iterator following the last removed element. Yes. So that means that we can just return position instead of position pointer next. So I want to return iterator. Oh, I really need to be able to cast const iterator to an iterator. Erase returns an iterator. Yeah, why not a const iterator? Yeah, what? Why does it return an iterator? No, whatever. The whole extract is not, we're just throwing the thing away. So we have to call it in order to destruct it and stuff. This is not what we return. So we're getting a node type equals extract before position. But I didn't want to pass an iterator, so we're going to pass the pointer. We have access to that. And then I must return simply position pointer. So this return is also wrong, of course. Yeah, don't return anything from here. Simply do this stuff. And then for that matter, you can just assign a node. And then here we have to destroy the node. Okay, I'm lazy. It's not possible. I don't like to call is begin here, really, because by the time I test it, I already know that it is not end. What this really does is just test that it doesn't point to the base, and we already have the base. I don't even need to test if it is tainted, actually. Well, we do here, but this is when you only have the iterator. But now we have the list as well. So the only thing I want to know if the previous pointer is or is not equal to pointer previous equals the pointer to the base node. So after incrementing it, it is not equal to end. And of course, it was not equal to the base node either. So we have at least 2 elements, right, after this. Which means that if it is not the first element, then it was the second element. And then maybe now position is equal to end. But I tested, no, that is not true. Okay, I'm slightly confused here. Position pointer previous is equal to base node. That would be the first element, and then position points to the first element. Okay. Increment position. It should always be allowed because position is not allowed to be end if you want to erase it. Now we want to assign the node that is going to have, that has to be erased. If position equals end, after incrementing it, we must remove the last node. So node becomes extract back. And extract back does not require fixing the taint. Can't find tag pattern. Yep, does not require to fix the taint, so now that is just extracted and node points to it. Otherwise, if position is not end, then we had at least 2 elements. If the thing that we wanted to remove is the first element, then we call extract front. And then the taint must be fixed if the list is empty afterwards. Now this is decrementing size, so this one better does that too, even though we don't have to test it. Else was not the first element. Extract the node before. I'm not convinced though that the position is not end at this point. Well, it isn't. What the fuck? The position is not end, yeah. It's not end, it's not. We also don't want to extract it front thing. What is position now? Damn it. It's not end and it's not begin. But it was not begin to begin with anyway. Well, it could never have been begin, of course. Sorry. This says it was not allowed to be begin. It was also not allowed to be begin. Yeah, of course not. But it's extract before. Ah, so it's like pos -1 is not allowed to be begin. So you're not allowed to attempt to remove begin here, which means that you pass one more than the begin. aka pos -1 is not allowed to be begin. Pos is obviously not allowed to be begin here because you want to extract the node before that, which doesn't exist if pos equals begin. So the comment was wrong. And it isn't, because it was not begin before, so after incrementing it, it's not begin +1. Maybe we should say that instead. It's not allowed to be begin plus 1. So it kind of makes more sense. Yeah, so now we are allowed to call this. And this thing also does not require fixing taint, of course. It's just removing something in the middle. Cast that thing to a value so we can destroy it and deallocate it. And then we return position pointer because it was already incremented. That is, that would be my way to cast it from a const iterator to an iterator. Very dirty, but that should work. Yeah, or you can just use, I could use a static cast, but I'm still going to get a copy. Do that. The thing is, my iterator is derived from const iterator and does not have members of its own. So maybe I should add a const cast to it. Yeah, bullshit, of course. This is absolute bullshit. Let's ask Google. There is a solution with constant time complexity in C++ 11 for any sequence associated with an unordered associative container, including all of decentralized containers. You can call the range erase member function with an empty range. Seriously. bitcast. This was answered in 2022. In the meantime, we forgot where I was, that I needed this. Well, here. So I just want to have an iterator. That is const from position. Yeah, I mean, it's weird in itself. Like I said, that erase returns a normal iterator and not a const iterator, since it takes a const iterator. I mean, you would say, yeah. It used to be in a normal iterator. I mean, you destruct a thing. So passing a const iterator and then completely destructing the thing, that doesn't sound very const. But that's also how free works and delete. You just are allowed, it's the last thing you do, and then somehow in practice turned out to tell everyone that it really should be allowed to free a const pointer. And then I guess this is the equivalent of that for iterators. But it smells, clearly. It's a thing that returns a normal iterator. Even answers on Stack Overflow that you have to use erase to cast a const iterator to the iterator. Erase an empty thing. Or advanced 0. It's all dirty as hell. But okay. Bitcast is defined where? I don't know. I already looked for that, but it is defined in bit. Never heard of that. Okay, I left something in, but we'll just see to make the error, I guess. That's what I left in. Maybe the rest will compile. It does not. Base node was not declared in this scope. Shocking. Oh, it's like that again. It's like that again, seriously. Oh, we get that 20 times more, I bet. There are no arguments to extract back that depend on a template parameter. So a declaration of extract back must be available. Yeah. Like I said, more of the same. Let's find all the others as well. What about size? That's probably not working. Although I'm not even sure. Let's see. Extract front, same thing. All that base class stuff is not accessible here for some reason. You gotta wonder if this not should not be moved to the base class. And then only this requires the allocator. All of this could be put in the base class, and then you don't have the silly prefixes everywhere. Don't need that anymore then. I might do that someday. I think the rest works. Okay, and we still don't crash because we don't test it. Yay, everything works. So that was one erase. Now we have another erase here, which erases multiple things. I'm getting tired of this. I'll do this function and then I stop totally because I'm getting tired of it. And I'm going to turn on the light. Be right back. question. What the hell to return then? Two. If lost equals end prior to removal, then the updated end iterator is returned. If first loss is an empty range, then loss is returned. That's what we wanted to know. It's a bit casted again. So that was one of the answers. If you try to erase an empty list, then you literally have casted it from const iterator to iterator. The insanity. That's really a flaw in C++ standard. So again, this returns a iterator to the following the last removed element, aka last incremented. So we can do plus plus last, like here. Then do our stuff, and then return that bit cast. Yeah, now it gets really tough. So we have to run over all the elements and call destroy and deallocate on each of them. But I do not want to update all the previous and next pointers. I mean, I don't want to do that one by one. It would be too slow. Now, common sense tells me that it would be better to first detach the whole block from the list before starting to destroy them. Kind of sounds like splice. We have to implement splice anyway. So maybe I should first do splice and then use that here. Because I said before I never heard of splice and I never used it, but it came to mind. I think that's what it's doing. It just splices the list into two lists. Specifically, you can extract a large number of nodes at once. There's my splice. Yeah, well, okay, sort of. Or at least we have to implement a function that we can also use in splice. What does this thing do? Transfer elements from one list to another. Yeah, I don't want to do that. I just want to get a fake list of elements. No elements are copied or moved. Only the internal pointers of the list nodes are repointed. No iterators or references become invalidated. The iterators to move the elements remain valid, but now refer into this, not into other. Transfer all elements from other into list. The elements are inserted before the element is pointed to by pos, blah 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 blah. So basically first and last. What the hell is wandering? Transfer all elements from other to this. Elements that are inserted before the element pointed to by pos. The elements are inserted before the element pointed to by pos. The container other becomes empty after the operation. So that has nothing to do with the erase that I want to do. 3 and 4. Transfer the element pointed to by it from other to this. The element is inserted before the element pointed pos, so that's only a single element. Transfer the elements in the range first last. That's then the one that I want. 5 and 6. So it's kind of like extract, except that I need to get back 2 nodes then. the first and the last node. Let's call it extract range. So instead of extract node before, we're going to write an extract where loss is again, well, one past the last one. So remove the range first comma last from the list. I don't have to return anything actually. These things will still be valid, so whatever you pass is returned. Although, no, there is a problem with last. I think I want to get a pointer back to the actual last one. So let's just return node pointer. Returns the last element removed. Maybe I want to demand that it's not allowed to try to remove an empty range here. Anyway, the comment is going to be from yeah, for some reason I chose to do this like this. It's not the best ASCII art. It looks like this thing is pointing back to next, but it's not. So next points to this one, not to next. Just pointing to first minus one. And then the first minus one next points to blah 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 and so on, and so this one points to last minus one, which then points to last, but I'm not typing last here because then I have to duplicate last. I just type it on this row, so it's actually pretty confusing. Oops, the other way around. So this thing points to the object last. Or equals last, rather. It points to the object that last points to. So next equals last. It's just a really shitty drawing. But let's not put time in currently fixing it. And then we go to 2. And then of course you want to remove the whole list. Copy that. And then we want to remove, wait a minute, I want to paste that here. First minus 1, what is this for nonsense? First minus 1, this is just first. First minus 1 next points to first, which points to the second one, and so on. And then it points to last minus 1, which then points to last. So now we have the whole thing. And this must look the same initially. And then now we want to delete first all the way up till and including last minus 1. And this thing must still exist. Where last minus 1 is returned. Okay, so the remaining problem now is this special cases. For example, what happens if the range is empty or stuff like that. But ignoring all special cases, we would do something like update this next pointer and update that. Maybe we can start with this one as usual. So the previous one is, well, no, we learned from this. I'm going to begin with the thing that we want to return. So last minus 1 must be assigned, and then I'm going to return that. Now last minus 1 is the thing that is pointed to by this, but it's a bit hard to detect. So this one, last previous points to, of course, last minus 1. And then after we copy that, we can correct last minus 1, last previous, because that now has to point to first minus 1, which is being pointed to by first previous. And we also have to update first minus 1, which happens to be last previous or still previous first. Let's use the last previous. Did I do that here as well? Yeah, see, the thing that just was assigned is being used, so let's just do this, which is first previous, which is first minus 1, and we must update first minus 1 next to point to last. So all done, I think. It should be fast. Yeah. So now the problem is a possibly tainted previous or a possibly untainted previous, if that is the base node. So here we're using a previous. Can last be the base node? Well, that can only be the case if last equals end, and that is possible. And if that is the case, then we want to return end. So we want to return the base node because that is end. Yes. So this is perfectly fine, but I must untaint it just in case. In case last is end, so I'll even add a comment for it. Untaint in case last equals end. And then last previous is set to, now we have a problem because this must only be retainted if last equals end. So maybe I should just make a special case of that then. So I have to only test that once. Let's do that. So in this case, we only have a node pointer and not a. Well, of course, we have a list. This is a member function of the list. Yeah. So if last equals end, then last equals the base node. Pointer to base node thingy. Else actually nonsense. Let's just use a return here. Return. So I don't need an else. Don't need an indentation. Don't need to define it. And now last is no longer equal to end, so we don't need to untaint it. To indicate that last equals end, we must return end. That's what it said here, I think. This is splice. Well, splice doesn't, but erase had to do that. Let's go back to erase. If last equals end, then the updated end iterator is returned. Okay, the iterator constructed from the list. Apparently, do we have to look at the iterator constructor from the list, which is not in line. Why the hell is that not in line? A const cast, because the list is const, no. Because no apparent reason. What is the const cast doing here? What is the const cast doing here? It's bullshit. Plus the thing should be in line. It can hardly be shorter. But yeah, so that sets the pointer, which is this thing here. If we're talking about node pointers, then that's just the pointer to the base node. And I was working on, nobody knows. Somewhere in this class, I think, at the end. Struct range, yeah. So, return pointer to the base node means end. Even add comment there, yeah. Return end. End as acronym. Normally I don't use a parenthesis for functions in comments, but in this case probably just required to be clear. Okay. Kanishki says your code hurts me. You can look with just one eye, that might help. Okay, what was the problem here? If last equals base node, then because then you don't need to use the mouse, and it's way faster. I'm still using the mouse, as you can see, and the thinking mouse. Nah. I don't know. If I mean, one of the main reasons is that say you are here and you want to jump to the end of the line. It's a single character. Begin of the line to the capital A. The matching brace parenthesis to the end of the function. It's all one. You don't have to move your hands from the keyboard. You just have to type 10 fingers. All the fingers are on the keyboard. And a single character moves my cursor to a lot of places. That's the main reason. I'm not using them. Usually I just do this when I want to go up. Well, I also could have pressed that. Oh, that's the way. It's too far. That's actually cost us because of that. So empty line. Jump to the previous empty line. Could be done in one go, but yeah, I'm thinking anyway, so I might as well type 3 characters. I don't know. I'm probably not that much of a wizard when it comes to moving my cursor around in Vim. I'm using a lot of this kind of stuff, character by character. I might as well do that with the cursor keys, but hey, at least I don't have to move my fingers. Because this is just J, K, L, and H. So I'm almost have my fingers on those keys anyway. So I literally don't have to move a finger, except pressing it. If I want to go up, down, the fingers are already there for touch typing. Okay, so clearly getting tired here. I kind of want to do this, but now last equals end, which means that we have to untaint previous, but I don't need to do this in the first place because we just return a point to the base node anyway. Directly, so I don't need this. We still need to do this though. And the question is, can I do that? Well, last equals end. I totally can do that, except that I have to untaint the last previous. Oh no, that was just assigned. So as long as first previous is not end. If first, well, wait a minute, first cannot be end, right? Well, it can. If first and last are both end. Okay, so I'm going to add a comment that is not allowed. I mean, these functions, these private functions are aimed to be fast, so I definitely don't want to do too many exceptions. In this case I am, because otherwise the other code becomes horribly complex. But these, as you see, they don't make any exceptions. They just execute 4 lines of code, period. And then if that only works under certain conditions, I add a comment that can only be called under those conditions. In this case, I make an exception for this, but I'm not making an exception for empty list. So the range is not allowed to be empty. Which then automatically means that first is not allowed to be end, and therefore previous is not tainted. And thus last previous is not tainted, and therefore we can just dereference it to next and assign last. And last is also not end. Oh, wait, last is end. But that's okay. And then we return that. So yeah, done. Yeah, no taints, untaints necessary. Okay, but that was just looking at this previous here, which is tainted if last is end. This previous should be tainted if last is end, but last is not end, therefore it should not be tainted. First is not end either, we just added that in a comment, so this previous is not tainted. And again, this one is not tainted, so we can just assign last and return it, and we're done. I don't think I need an exception for first being begin. That's kind of strange, so I have made that exception before. So I have an extract front here. Oh, yeah, right. Wait a minute. No. Yeah, actually. So, well, this should show me what the problem is. If we remove front, then okay. The only reason that extract front is a problem is when after that extraction the list is empty. Because then base node next is actually the base node, and then we assign previous, which must be tainted then. Which surprisingly was not the case if we remove the last node from back, extract back. How the F is that possible? To look at it again. Oh, because it does contain untainted. Huh? No, wait. Oh, it does contain taint, sorry. In this case, we know that it is the base node, so it's tainted automatically. Well, in this case, it's only the base node when the list becomes empty. So then, well, I don't want to test that here. So I already made an exception for, I mean, if for last being end, if last is not end, then we don't remove the last element of the list, which means that this problem does not exist. So the untainted and tainted. Also not having an untainted and tainted though. In my special case, why not? That seems very weird. Oh, because you get the first for free. So extract range is equal to extract back if and only if last is end, and first equals the last element in the list. But that means that we don't have to access last previous. We can just use first. And since we're using first anyway, the error, the problem does not occur that we have in extract back. Yeah, I don't see a problem with it. So last previous. Yeah, this is nonsense. Nah. If last is end, then this is the base node previous. So the thing must be tainted. I'm just going to literally use base node here. And taint is necessary. And then now it is tainted, so we can't use the base node previous, nor last previous, but I can still use first previous. Because first is guaranteed not to be end here. Base node previous. That's correct. Yep. I think it's correct. Okay. So now I can use this to implement splice, but you can also use it to implement erase. Which I'm going to do first. So we already checked that it is not an empty list. And then we increment last, which must also be returned, which is then passed to was lost. Oh, did you get reuse lost? No, definitely not reuse lost. Not sure that this is possible though. What if loss is already equal to end? In that case, we must return end as well. I think if loss equals end, then end is returned. If loss is not end, yeah, loss remains, right? So then it is the next element. It's always the next. Oh, it's always loss incremented. Loss one. Loss is loss one. Loss is just what you. Loss equals end and updated end is returned. Yeah, I mean loss is returned, I would say, but maybe this makes sense somehow. Erase is also, this is erase. Erase also as an, see, open. So it loss is already one past the last one, so we don't have to do that. All this last extracted. It's a bit confusing that sometimes last means one past the last one, and sometimes last means actually the last one. I don't like that. I would use end here instead of last, but well. End is kind of reserved for the end of the list itself, not for a range. So apparently they use first last for ranges, where then last is one past the actual last one. So it's not really last. But in this case, it is actually the last one that was extracted. So it's not one past that. So I need a new word. What? Right, so I think we did everything in one blow here, except calling destroy and deallocate. So now we have to run over all the nodes. I'm starting to be slightly unhappy with having to value cast this. But yeah. Okay, so we have a for loop. Okay, just run backwards or increase first now, or what do we do? I think it's a not empty list, so we begin with do, and then we are done if first equals last. Sorry, if first equals last extracted. Which means that we begin with deleting first. So I'm going to, we have to do this then, which is annoying, but first, I'm just going to reuse first. It is the way it is, I think. Well, actually, my value type has a next, I think. Value type. It has a next. I could get an iterator. Okay, maybe I should use an iterator. Yeah, it's doing almost the same thing. First is an iterator. Last extracted is not. So let's make an iterator here. We can just make an iterator or a const iterator. So I can construct a const iterate from a node pointer. So extract range returns a node pointer to the last element that was removed. And then we can construct an iterator from that. And then I can simply do while that. And then this is easier because if I dereference a const iterator, I get a value type. So we don't have to do this anymore then. So I can do, well, I get a value type reference. Yeah, except that value and must be a value type pointer. So I'm just going to use a value type pointer, I guess, and that means that we have to dereference it and then take the pointer with it. Looks a bit stupid, though, but okay. So somewhere we have a dereference operator, which static cast reference. No. You see, I should just use this. I think I have direct access to pointer anyway, so maybe I should just call. Fuck me. Get a notification that gives me a heart attack. So loud it is. Static cast pointer. It should be nice if I could have, if I had a function that just returned a pointer. What is a pointer anyway? That is, I think, just a value. A const pointer. Because it's a const iterator. But I think I redefined that down here. Yeah, this one. That is that one. I'm just gonna not do this. In other words, we're going to do the static cast of the pointer and access the pointer directly instead of calling the star and then get a reference and then having it cast to a up and down and reference and pointer and back again. Nope. So I want a static cast to value type pointer of the node pointer. Which is actually just my value type cast. So maybe I should just use that then. Otherwise I don't have access to something. Yeah, we have to do it like this. Okay, and then this is again base class stuff, static to list base t value class type first pointer. And if not, then anyway. Did you mean base node? Yes, I did. Is required from using const iterator required from here. The valid conversion from node pointer to list based node pointer. That's probably const here, way away from the actual pointer. And where is that happening? That is happening here. Is that new code? So that's why the static cast was the const cast, I mean. I really don't get it. But there was a const cast here, I remember that. So apparently I had it right. Const cast. Okay. const cost, you win const cost. No, it compiles. And the original program still works. I'm going to stop for today because horrible. It's just horrible to do this. I do need to know what to think about though while I'm laying in bed. So what is the next thing that I have to do? Class list. So I just did erase, I think. That's it, erase. Oh, I did this one. Yep. Push back is done. Push front is done. Resize is the next one. Still lots and lots and lots to do. Hopefully you can do that in one day. Otherwise, 2 days. I do have some other stuff to do though. So maybe 2 days more, 2 more days, and then really it must be finished, man. Apart from sort, of course. That's gonna take a week. Already totally sick of this. But yeah. Let's lose a game of chess and then go offline. I only know one opening, which is Sicilian. What? He takes back with the queen. Fuck. Why the hell did I pre-move? Oh, this sucks. It's like the first time that I pre-move. And then a little normal. I always wait, you know. I only pre-move when it is a capture that will fail anyway. If they don't do the move that... Unbelievable. And then they do something like this. Take with the queen. Can I still punish it? I think I can punish it. I take a piece. They take a queen. I take a queen, and they take a piece. I can take a piece like this, and then I still have a fork to worry about. Okay, I can do this. Threatening. I can just take here now, actually. Threatening the queen. So he's going to take back. You could take back with the queen. Threaten to take here a check and then getting my queen. No, nothing is good. Oh my, now I leave my knight. So I'm going to lose my knight? Really? No, I can take like this. That saves me a knight. If I take here, it just takes my knight, and I'm like, I'm already a piece down. Oh, I don't. What the hell happened? Ah, so painful this. I can take back here, yeah, I take a pawn and he takes another piece with check. I can take back then, but still a piece down, man. Then I get this knight. I can't defend this pawn. I could have castled more. No, then he can take this pawn. I can take that pawn anyway, actually. They maybe not advisable. So pinch. The knot is pinched. Seems he missed this one, though. Oh, he did not. It did not. +4. Oh, I hate this guy. Oh, I hate it so much. And then if I go here, oh, he has to take it, yeah, because this is pinned, so then he can go there. Yeah. Of course he takes. So now my knight defends that at least. But if I move it, so I can't even defend my knight. So he's going to double the rook, and then I have to move my knight. And then he can escape with check. I can't go anywhere. I should just give up. Okay, I go here right now. How about that? But yeah, the bloody thing is still going to escape. Oh yeah, now he pins it. He's still going to take here. He thinks I can't play speed chess. Oh, there is another fork. I thought he was like sacrificing something, like I win on time anyway. But no. No. What is this? This is too sad for words. I'm not going to resign. I just refuse to resign. Oh, now he's sacrificing. No, you can't have this one. Sorry, you can't have that one. Why is he getting... oh, he's getting a bishop, of course. Yep. Now, give away all the pawns. Now, you think he can do it? King there, yes, very good. Go there, there, that would be too fast for him. I'm going to cut off the king instead. Almost. If you was like make this triangle, then it would have been draw. It was the nicest thing that went away. But he did not fall for it. Now I could do it. I'm gonna go here, I think. I just will go here. Why not? Oh no, I'm in the corner. It's going to make me. Shit. Shit. Yeah, that was a good cutoff. Now there is not much left. Could just go there as well. So, there's nothing we can do here. Try to walk back. Is it letting me walk back? No, it's not letting me walk back. That would be made. Yeah, he's going to cut me off. It's finished. Yeah, you got it. Yeah, I know how to mate with the bishop and the knight as well. And if I ever get someone who doesn't give up, I do the same thing. I just get a bishop and a knight and then give everything away. And then I really hate it when they don't let me mate them, then resign. So I didn't resign, I just let him do the thing with the bishop and the knight. But yeah, see how low my rating is. It's really to set words. I have to win a game. I hate French. And I think I even got a tempo more. Still I don't know what to do. Oh, I gave a pawn away. Really? Why and how am I doing that always? This kind of stupidity. Yeah, well, not seeing pieces and pawns that you drop. That is not a good thing. I mean, that's a good reason to lose all the time. That is a pretty good move. Except that his king is still in the center. I'm just going to take it. Oh. Oh. Okay. Can't move my knight. Whoa. And if I take the rook, I just lose. It's made on 1. Oh no. That's not unbelievable, this. I can't play chess. I really can't play chess. I just can't play chess. Go here, take, walk, goes there. I go here. He just pushes. Not working. If I push now, maybe I'm threatening to do this. Suppose he moves the bishop, and I do this. And if he takes, I take, I walk. That is not possible. If he doesn't take, he has to come here, under protection of the king. But then I can take it and I still have this pawn. I think this might be the right move. So now my next move would be this. Threatening to move and then take the bishop. If the bishop goes like this, I get this promote. If he tries to capture it, I take the bishop and promote. Should be good. You can't do this, I just take it. Take back, I walk. Wait a minute, that's not good. So I go here, he does that. Oh, then I push it. And then he can't take it because I will take the bishop. If we take my bishop first, and I get a free pawn here as well. That's not good enough. I would like to walk this way. So I go here. I can't go here. Man, why is this so difficult? Maybe I should just collect this pawn. Leave the bishop here. You could play the bishop there and then there to attack it. That's the only way. But yeah, I mean, I can't do that because if say I go here and he puts the bishop there to even stop me on, then my bishop comes here. No, then I push my pawn. No. Then my bishop comes here. Does it? No. It goes back, I push this, it takes, still not good. Hello, user 3245. I'm here. What is the solution here? Maybe I do this. If he takes and I take back, he can't stop both pawns. He must stay in this square. So I can just walk at this pawn then. For example, take, he goes there, I do this. If he takes that pawn, yeah, I walk. So this must be the move. No, I can't take my pawn because then I take the bishop. If I do something with my king, which seems nonsensical, then he could take it, I take, and he takes that. That's not good. So I have to push right now. And then I'm threatening to take the bishop and promote. But he could stop me by putting the bishop there. But then I promote, and then he has to take it to the bishop, and I win. Yeah, this is the move. What the fuck? No, 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 no. Why? How is that not the move? Is this the move? No. Then this is the move. But why? Oh, because now I exchange the bishops while still having this pawn. Okay. Yeah. I think I should give up playing chess. It's way too difficult for me. It seems. No, I think queen here. Nope. Starting to get lazy too now. Yeah, well, why queen d4? Check, and then well, he has to go there and then check like this. Then I get there with check. That's probably better. Oh, he goes there. Rook here, threatens maiden one. You can give check here. No, not after the rook there. And now the queen here. The pawn? Why would I move the pawn? It just takes it. I had the last move right, but I did it immediately. Okay. pure horror. I'll be back here tomorrow with C++ until I can also not anymore code, I guess. I don't know what I will do then.